Everyone from Khan's Econ Nugget channel. Today we are going to discuss optimal resource allocation rule and a couple of examples. So optimal resource allocation rule says that the hiring manager or the economic manager has to apply the allocation rules such as where the marginal revenue product from an input or resource has to be equal to the resource's price that the hiring manager is hiring. So in this case, we're going to keep it simple and we're going to use only one input, which is labor. So the resource price in this case will be the labor price, which means the wages or salaries of each worker. And MRP, which is marginal revenue product, that we're going to explain as the marginal product of an input, in this case labor, multiplied with the price of the output that that input is producing. So in this case, if this is a donut company and the donut is sold at $20 a dozen, then if the first worker number one here on the column number one, if that worker's marginal product is 10 dozens of donut, then marginal revenue product, MRP, for first worker will be 10 times 20, which is per dozens of donut sold, so which is $200, right? So that's why we see on the column number 5, for first worker, the MRP is $200. So now we come back quickly to go over those all those 6 columns one by one. So column 1 is basically presenting the data about the input that is being employed. So worker can be hired 0 worker, 1 worker, 2 workers, 3, 4, 5, 6, 7, 8, etc. Column number 2 is measuring total product. That's the contribution of the employed resources up to that point. So it's cumulative, right? So if the total product is 25 here, which is corresponding to the labor unit 2, that means 2 workers together produced 25 dozens of donuts. If the total product is 45, which is corresponding to 3 workers, then we have to read it as 3 workers combinedly produced 45 dozens of donuts, etc. So then column number 3 is measuring the marginal product of a particular worker. So for example, if worker 1 has a marginal product of 10, how we found that? We found that by taking the difference between total product when there was no workers and when there is 1 worker. So this difference is 10, and we divided that by column number 1, change in column number 1, right? So column number 1 change was 0 worker and 1 worker, so change was 1 here. So column number 2 item was 10 divided by change in column number 1 was 1. That gives us marginal product of first worker to be 10. Similarly, for the second worker, over here, marginal product is 15. How? Because the difference between total product when only 1 worker worked, that's 10 dozens of donut, and then when 2 people combinedly produce 25 dozens of donut, so that difference between 10 dozens and 25 dozens is 15 dozens, and divided by change in worker, which is the difference is 1. So 15 divided by 1 is 15, which is marginal product of second worker. Here 20 divided by 1 is 20, which is the marginal product of third worker, etc. And similarly, we see marginal product of sixth worker here is 5. How we got that? So the total product of 5 people combined was 70 dozens, and 6 workers combined was 75 dozens. So the difference between 70 and 75 is 5, divided by the number of worker change is just 1. So that's 5 divided by 1 is 5, etc. And notice that it can also be 0. Marginal product can also be negative. For example, by the time we hire 8th worker, the kitchen is so congested that out of 8 people, the output indeed was even less than the combined output of 7 workers. So 7 people combinedly produced 75 dozens of donut, whereas 8 people together, maybe due to congestion of that kitchen, the actual total output was decreased. So it was only 70 dozens, which is a decrease of 5 dozens. So that's -5 for the marginal product here. Now we see the column number 4 is just putting a wages of the workers. Here we are saying that assume if each worker is receiving a flat pay of $100 and each dozen of donut is sold at $20, then what will be the optimal number of workers to be hired? So we are answering this question, right? And applying the optimal resource allocation rule, which is called MRP equals resource prices. So MRP stands for marginal revenue product, which has to be equal to the resource prices. In this case, the workers' wages, flat pay is $100 here. So here we see that when there was only one worker hired, marginal product was 10, and therefore MRP out of that first worker was, so the 10 times this 20, the donut price, right? So 10 dozens was marginal product and each dozen was sold at $20. So marginal revenue out of that first worker to be obtained was $200. Similarly, from second worker's marginal product was 15 dozens of donut, which the company could sell for $20 each dozen. That means they'll be making $300 out of the second guy's marginal revenue product of second guy, right? Similarly, marginal revenue product of third guy is $400, etc. And now we have to see that at which hiring level this optimal resource allocation rule applies, that where MRP equals resource prices, right? So here we see that equalization happens by the time they hire sixth worker. With that sixth worker, marginal product is 5 dozens, and therefore marginal revenue product will be $100, because 5 dozen times each dozen is selling price is $20, so 20 times 5 is 100. So here we see that the wages paid for the sixth worker and the marginal revenue product of sixth worker, they're equal, so both are 100. So in this case, the optimal hiring will be 6 workers. But why seventh worker will not be optimally hiring? Because if seventh worker we hire, then the marginal product of that person is 0. That means that person did not bring any revenue for the company. So then the company would not be interested in hiring that person and paying that wages, right? On the other hand, why hiring fifth worker will not be optimal for the company? Because the fifth worker's marginal product is 10 dozens of donut, which means company could earn $200 out of that person's work. So that means if the company stop at hiring at the fifth worker, then looks like the company would miss out on additional revenue opportunity, because looks like the sixth worker here could bring in, could just pay for the person's cost. So that means the company will be better off by hiring to the point where the marginal revenue product of that worker is equal to the cost on that worker, cost in the form of payments of wages and salaries, right? That is why the optimal resource allocation rule is MRP, marginal revenue product, has to be equal to that input's prices or wages in this case, right? Similarly, we see one more example using similar data, but we just change the wages. Here the wages are $200 each worker, and the donut price is $10 per dozen. So here now we see the optimal hiring amount will be 3 workers, because at the third worker's marginal product is 20 dozens of donut, which means the marginal revenue product is $200, which is 20 times $10 per dozen of donut. And the workers' wages are also 200. So here the wages 200 and the marginal revenue product 200, both are equal at this hiring level. So in this case, optimal allocation of resource would be 3 workers. So we have to just remember that when we use a single input based this kind of exposition, we have to make sure that the optimal allocation of resource will be the point at which the marginal revenue product of that resource has to be equal to the marginal cost of that resource. In this case, the wages, right? So wages has to be equal to the marginal revenue product of the labor to find the optimal allocation of, in this case, labor resources. I hope it was clear. The concept was clear. And if you have any question about optimal resource allocation, please put the comment on the chat box. Thank you so much.